Here we come to the example on page 22 with a car turning around a corner on a banked road. In this case, friction is involved. We see that there is 1200 Newton of friction acting inwards towards the center of the road. So, firstly, we would like to find a normal reaction acting on the car by the road. In order to look into this question, we'll try to resolve the normal reaction into the component which is horizontal and its component which is vertical. So we have n cosine 5 degree. And also we are going to resolve the friction into the horizontal component f cosine 5 degree and the component which is vertical given by f sine 5 degree. Now, so let's write an equation by considering the vertical components. The vertical components, upward we have n cosine 5 degree, and downward we have mg and f sine 5 degree. Therefore, we can write down upward force n cosine 5 degree equals downward force mg plus the component of friction f sine 5 degree. Putting in the numbers, n cosine 5 degree will be equals to m 1500, g 9.81, and plus friction is 1200 sine 5 degree. Solving this equation give us n will be equals to 14876 Newton. Part B. Find the centripetal force that the car requires to turn around the corner. In this case, when we look at the free body diagram here, we find that the force that is pointing towards the center, or in other words, the centripetal force, is given by two components. First of all is the component of n, which is pointing in a horizontal direction, and secondly is the friction, which points towards the horizontal direction. So when these two forces add up together, they provide the centripetal force. So we can write down an equation saying that by F equals ma. Now the force is given by two components. Firstly, n sine 5 degree plus the F cosine 5 degree. Okay, so these two forces add up and becomes the centripetal force. Putting in the numbers, Fa will be equals to n sine 5 degree plus F 1200 cosine 5 degree. And that would give us 2491. 2492 Newton. So this is the force that the car requires, the centripetal force the car requires to turn around the corner. Part C, find the speed of the car. If we want to know the speed of the car, we have to consider now the car is turning around a corner, so that we would have a centripetal force And this centripetal force is provided so that it will provide the centripetal force of the car required to turn around the corner. As we already know that how much force is required to turn around the corner, we can write down the equation F equals mv squared over r. F is the centripetal force, so it's 2492. Mass is 1500. V is what we want to find. The radius of curvature is 575. So, solving this, V is equals to 30.91 meter per second. Lastly, usually when we turn around the corner, the road will be banked to the inside. However, let's say if we have such a design, when the road is banked outside, you are required to explain whether this design helps the car turn the corner or not. When we try to resolve the force, because we know that the car will experience, firstly, we have a normal reaction force. Secondly, we would have a mg. Here, in this case, if we resolve the normal reaction into its horizontal component, so we would have n sine theta and n cosine theta, provided that the banking angle is theta. Now, so here we see that the horizontal component of the normal reaction actually points outwards. However, in order for the car to turn around the corner, we should have a force to point inwards, but this time the force points outwards. So it does not help the car to turn around the corner. So how to explain that? Because the horizontal component of the normal reaction points outwards. It does not help to provide the required centripetal force in order to turn the corner. Therefore, the banking does not help the turning.